Thank you. Yeah, from yesterday, it was, what, Tuesday, it was sunny and everything. Now it's cold, wet, and freezing, or colder.
I think from here on out, it's gonna like get colder, because rain always cools it down.
Right,
By us.
yeah. Because what that means is the clouds are a lot lower, which means the atmosphere is a lot thicker. So it usually happens on low pressure systems and between high and low pressure systems. All right, let's finish this.
Almost.
Oh, excellent. Yeah, and I want to talk about also, because I think we may skip 5. We do chapter 4 and then jump to chapter 6 because we're so short in time. I want to get to the important stuff to see where this stuff is related to everything else.
At least chapter 3, almost done.
Yeah,
And then, like you're just saying, we'll go as far in the assignments as we
if we can.
like when it comes to how far we are.
Right.
Okay.
All right, so what we talked about so far is the variance and deviation. What's the difference between variance and deviation? Yes, the variance is squared. Whatever formula you're going to use. The deviation is the square root of it. Whatever formula. So far, we've discussed 3 different formulas for variance and deviations. And what do they tell us? What does deviation tell us? Why do they call it deviation? That's a very big answer. It varies from something. Yes, by definition, deviation means that. Anybody be more specific? Right. How far the data value vary from the mean, and the deviation is just that. It's just the deviation by definition is simply how far something moves off course. Because if you're supposed to, like a ship going straight or an airplane, if the wind blows it, it doesn't go straight anymore. It deviates to one side wherever the wind's blowing it. Hence deviation. Can we compare 2 variants or 2 deviations? In other words, if let's say on one of the examples, let's say you had a math exam and then an English exam. If you made 80s in both of them, but the deviations were different. What does that tell us about the data? Does this mean you're equally as smart in both of those classes? Why not? What does that mean? What does that have to do? I mean, yes, it's true, but what does that have to do? Why does that matter? How does it matter? No, I mean, you made an 80. You made an 80, you made an 80. It had nothing to do with the test itself. It's your intelligence answered those questions correctly 80% of the time. But what does deviation relate to? From the median or mean? Mean, yes. From the mean. Because even though you made an 80, what this tells us, because the deviation, this one's smaller than this one, that means the group is, the test scores in that one are more condensed, which means a lot of the class made around that score, as opposed to a standard deviation of 10, which means they're further dispersed. Well, we have something to talk about to be able to convert these two. It's called the coefficient of variation, or the CV. Some places you'll see as CVAR. But what this does, it takes just that we just talked about. Even though the score, this is your score, this is your standard deviation, it takes those two in consideration. The CV formula is the standard deviation divided by the mean of that object, of that class, times 100%. This is for a sample, of course. How do we know that's for a sample? Mm, I know you know the picture. That's called mu. But populations, the sample, easiest way to look at it, the sample uses our alphabet, A, B, C, D, E, F, G, whatever. Populations use the Greek alphabet. So that's how you can tell if you look at two things. If it's in Greek, if the symbols are used in Greek, that's population. That's exact answer. If it's written in our language, our alphabet, then it's a sample. So it means it's only an approximation of the population. All right, so let's look at an example. The mean of the number of sales of cars over 3 months is 87. And the standard deviation is 5. That's group 1. Now we're going to compare it to group 2. The mean of the commissions on these sales is 5,225, and the standard deviation is 773. Compare the variations of the two data sets. So it gives us two separate, it's the car sales themselves and then the commissions that are associated to those car sales for those 3 month time. Everything's the same, but we have two different data sets. It's like comparing apples to oranges. They always say you can't compare apples to oranges. We kind of can, just a little bit. If they share the same something, they have to have something in common. So how do I do this? How would I compare them? Not really. No, we have the mean's given. So the group one, here's group one, group A. The mean is 87. And the standard deviation is 5. Group B, its mean is 522.5, and its standard deviation is 773. This is in dollars. That's in number of sales. The only way we can compare them is to compare their coefficients of variance. Not the only way. There are other ways we can do it that are much lengthier, much more time consuming. So what we have to do is find the CV of both of these and compare the values. So the formula is the deviation over the mean. So it's 5/87 times 100. So let me see here, 5 divided by 87. Is 0.057 times 100. That converts it to percent. So it's 5.7%. So the CV of my A group is 5.7%. The CV of my second group, group B, is 773 over 5,225. That's going to give us 0.148 times 100. The CV of B is 14.8%. So what does that tell us? Remember, this is the coefficient of variability. So since this number is bigger, it tells us that this data set has more variation of the data. That's all it tells us. It can't tell us how much bigger it is than anybody else or less than anybody else. That's all it tells us is the data itself has a lot of variance. You could, that's nothing. That's why you can't really say anything. It all depends on how you define it. Because if you want less variation, like the paint samples, you want those to be more condensed. The type of questions, what you're, yeah. So there's no one right answer. It all depends on what you're looking for. You want to do another one? You're okay with that? Because all it is your deviation over your mean times 100. So let's move on. So we learned all sorts of different formulas for standard deviation. Yesterday, or not yesterday, but last class, we had that shortcut. It was a shortcut, but it was a longer equation. It's a lot of work. Is there a shortcut of that shortcut? Yes. There's an approximate, remember, first off, samples are approximations of populations. So we have a formula you call the range rule of thumb. Where the standard deviation, anybody know what this squiggly line means? Approximately. So this deviation is approximately the range of your data divided by 4. Good question. Can anybody guess why it's 4? Hmm? But why would it be 4? That goes on with what we're gonna talk about next, has to do with normal distributions. And we'll talk about more about this, especially when it comes to the Chebyshev idea. As I asked before. The only thing that changes is the range. I mean, remember, this is a rough rule of thumb. It's an approximation. So what you'll get there is a ballpark idea. First off, you say, what is the range? What's the formula for the range? Right. We'll have an example here. Yes. The standard deviation of this data set is 2.7. We could go, how would we find that? How would we find the standard deviation with this data set? The shortcut, we have the formula of the n times summation of x squared minus summation of x squared in parentheses divided by n minus 1. We could do that. A lot of work. Or let's check the shortcut, see if how close it is. So what's the range? 13 minus 5, which is what? So 8 minus 4, or 8 divided by 4 is 2. So what this one says, it's approximately 2 as opposed to 2.7. That's pretty close. Especially when you would use this only when you're in a hurry. Just how does it look? Which one's better? That's all you'd use it for. Okay? Let me see, is there another example? If I had two separate deviations, I'm gonna say, so if I had two separate deviations, I would first have to find out which, so if I gave you both of these, they're of the same data, but without knowing which formula they came from, you really can't see. And even if you did have the same, make sure it's a data set, because this one only has how many? 8, 7, 1, 2, 3, 4, 5, 6, 7 pieces of data. Or if this one was n equals 7, what if this one n is 100? So this one's more accurate than that one because the data set's larger. So the larger your data set, the more accurate to the population your approximation is going to be. There's another way we can approximate these deviations. Chebyshev's theorem. Chebyshev was a Russian mathematician who statistician who did a lot of research with all sorts of shortcuts and different ways we can approximate these statistical analyses. And see what it finds there. Here's. He stated the proportion of values from a data set will fall within K standard deviations of the mean. The proportion of the values from a data set will fall within K standard deviations of mean will be at least 1 minus 1 over K squared. Where K is a number greater than 1. It doesn't have to be an integer. It can be a decimal, it can be a fraction, whatever. But it has to be bigger than 1. The reason for this, because if it's equals to 1, then what do we have? 0. If it's less than 1, then we have a negative answer. How do we have? In other words, if K is 1/2, what would our answer be? What would our Chebyshev value be? If K equals 1/2. Now, you can't use the word can't be like in mathematics. Just work it out. Don't guess. This is a math class. No. Well, let's look at this. We have 1 over 1/2 squared. 1 minus 1 over, square the top and bottom, so it makes it 1 over 4. What's the rule about fractions over fractions? Is 1 a fraction? Yes, every number is a fraction. 3 is a fraction because it's over 1. Every number is a rational number. So this number up here is 1 over 1. Whenever you have a compound fraction, a fraction over another fraction. Anybody know how to solve that? Take the top fraction, leave it alone. Flip the bottom and multiply it together. So nothing cancels. 1 times 4 is 4 over 1, which is 1 minus 4, which makes it negative 3. So that's why we keep our values greater than 1. If it's greater than 1, that means this will be a decimal. If this is greater than 1, that means this is guaranteed to be less than 1. So it's not going to be greater, it's not going to be less than 0 or less than 1. So what this thing says, the formula, 1 minus 1 over K squared. This tells us the number of standard deviations our data value is from the mean. That's what the whole thing just said a second ago. Now, what does that matter? What this he says is this theorem says that at least 3/4 of the data values will fall within 2 standard deviations of the mean. of that data set. Let's see how they got that. 2 standard deviations. So that means K is equal to 2. Remember, K is the number of standard deviations. Again, he was Russian, so they didn't use S like everybody else. They used their own language, Cyrillic language, and look like a K. So we have 1 minus 1 over 2 squared. 1 minus 1 over 4. So it's 4 over 4 minus 1 over 4 makes it 3/4. 3/4 is the same thing as 75%. It says it will fall within 2 standard deviations of the mean. So here's our mean. We have 1 standard deviation, 2 standard deviations. One standard deviation going to the left, and 2 standard deviations going to the left. We keep on going. We can go 3 standard deviations. Why is it negative to the left and positive to the right? What's that? The mean is only what it's up. The mean can only be positive.
How far are we from-
Well, if this was a mean, then any number to the right of it is going to be positive. Any number to the left of it will be less than, so it'll be negative of that value. And we'll show you how to get these actual values later on. So what it says is within 2 standard deviations, 75% of the data fall in there. It has to be 2 standard deviations from the mean. So the way it works is this, and this is why I want to jump to chapter 6 after we do chapter 4. Because I'm thinking about doing chapter 6 after we do this chapter, because that will take us to how this stuff is really used and how we calculate things with it. Chapter 4 is probability, and I wouldn't mind saving that to the end so we play games. So I think after this, we'll jump to chapter 6. And this is, I'll jump ahead. Let's say your average was 50. And your standard deviation was 10. So what this says, since your mean is 50, the first standard deviation is 10 bigger than 50, which makes it a what? 60. And that's, the next one is 2 standard deviations. So it's 10 plus 10, so that makes it 70. This is 3 standard deviations, so it's 3 times 10 is 30. 30 plus 50 is 80. Right, because each one of these steps is 1 standard deviation, which is 10. Now I'm walking backwards. I'm going from 50, I go back 10, I make it 40. Another 10 makes it, and then another one makes it 20. So that's how you find these values. So what he said, what Chebyshev said is, no matter what your data looks like, it's going to have an average of 75% of the data will fall within 2 standard deviations. We know that only works in some instances. Because what he was looking at is if you had skewed data, that could be true. So if you had skewed data, then that could be true, where 75% of the data falls within the 2 standard deviations. Well, no, it's you take the standard deviation, whatever it is, since it's -2, this is -2 times 10 makes it -20. The mean minus that will give us this value here. This side, since it's positive, it's the mean plus 2 standard deviations. That'll give us this value. Yeah, once you find your standard deviation, you multiply it to 1, 2, or 3 and add it to the mean. Because it's your step size. Your standard deviation is your step size. So from the mean, it goes up 1 standard deviation. That's 10. Then 10 more, and then 10 more. Then from the going backwards, it's minus 10, minus 10, minus 10. All right, so let's look at an example of Chebyshev's theorem. The mean price of houses is $50,000. And the standard deviation is $10,000. Find the price range for which 75% of the houses will sell. So what do we know about 70%? That's 2 standard deviations. We can work it out that way also. We can work backwards. We have the standard deviations equals 1 minus 1 over k squared. We can say that 75% is equal to 1 minus 1 over k squared. Solve for k. But that I don't want to do that because it's a lot of extra work. Because it's a Chebyshev, we can use Chebyshev's theorem, it's 75%. We know it's within 2 standard deviations. How much would it be, before we go any further, how much would it be if it was 3 standard deviations? Let's say k equals 3. So 1 minus 1 over 9, that's 9 over 9 minus 1 over 9 is 8 over 9. So it'll be approximately, it's less than, if it was 81 over 9, it'll be 9.9. So this makes it what? What'd you get, Carla? What'd you get? No. Well, let's see. Well, because 9 goes into 8.1 times. Doesn't it? No, it doesn't that. Because 9 times 9 is 81.
88, but it was like 11 minus.
Yeah, we haven't done that, yeah. So let's see. So what is 8 over 9? Yeah, so around it. So it's 0.888. So it's approximately, you could say 9, or say 9%. 90%, because we have to multiply by 100. So what it says, so within 3 standard deviations from the mean, So within 3 standard deviations, it's saying that 90% of the data fall within that. And within 2 standard deviations, it's 75%. Again, it's an approximation. It's a very rough approximation. Are we okay with that? So we'd have to say, how many standard deviations do we want? So if they ask for 90% or 95 or 75%, you know what it's looking for. Now, the reason I said this is an approximation, because what we're going to be using in this course, you want to take pictures of these? Well, oh, okay. Okay. All right. Now, the reason I'm saying this is we're going to, in the rest of this course, we're going to look at something called, actually, no, we haven't finished that yet. There's no, let me see, the question asked, the mean prices, find the prices, okay, we haven't finished that question yet. We know that it says 75 or 90%, thank you. But we haven't done this question yet. The question is here saying we start off at 50,000 and each standard deviation is 10,000. And 75% is go for 2 standard deviations. So if we look at our sales, the mean is 50,000. What would 1 standard deviation be? Because it's the mean is 50,000, each standard deviation is 10,000. So what would this next number be? 60. The next one would be, and the last, this is for 2 standard deviations, and then 3 standard deviations would be 80,000. That's going to the right. Now going to the left. So this one would be, very good. The next one would be -2 standard deviations. And then this one would be. So the question is asking, what price range falls within 75% of the house being sold? 75% we know is 2 standard deviations. So it's between here and here. So the sale price will go from 30,000 to 70,000. That's what it's telling us. So 75% of our sales in this neighborhood will be sold between this range. What would it be for 90%? 90% of the sales are between what prices? It's 3 standard deviations. Yep, between 20 and 80K would be, so 90% of our data houses would be sold between 20,000 and 80,000. So that's how we use standard deviations and these formulas. Any questions so far? Now, in general, whenever we talk about a normal distribution, you guys know it as the bell curve. What does the bell curve look like? Yeah, you can say, yeah. Yeah. I always thought it looks like a hat. Like a soldier, like a Japanese soldier's helmet in World War II. It's supposed to be top dead center. The middle is the mean. And then we have 1, 2, and 3 standard deviations on both sides. So within one standard deviation from the mean, 68% of our data fall within that. Within two standard deviations, 95% of the data fall within that. And within three standard deviations, we're looking at 99.7%. That's the normal distribution. And it's been verified and tried so many times. So we know that the mean is in the middle. It always works that way. So what does that mean? How much is here? And these are called tails. How much is in the far right-hand tail? What's that? 100? No. No. I see why you think that. What? No. I see why you think that, but no. You're close. It would be if I was looking at both of them, because three standard deviations is 99.7. So we're missing how much more? 0.3. That has to go in both of those. So since there's two of them, what's half of 0.3? 0.15. No. Well, they could be, but that's the reason they go out to the very outside. So it could be whatever they are. Remember, we haven't talked about what to do with outliers just yet. Because, for example, what would you do with outliers? They have to be part of the data. Because think about it. When I was in law school, there's a thing called the wailing wall. That's where the teachers posted their grades at the beginning of each semester. And they call it wailing wall because if you fail two classes in law school, you get kicked out. And okay, you're thinking, well, how hard is it to fail in law school? Well, the law school I went to graded on the bell curve. Here's what it means. This amount got the A's. This amount got the B's. This amount got the C's. These got the D's. Everybody else below that got F. So in other words, if the average grade was a 94 and the standard deviation was 2, remember, to go to law school and medical school, you have to be the best of the best in the first place. So if we had an average of 94, what would one standard deviation be? Right? You add 2 to it. This one would be, and this one would be 100. Going the other direction would be so between these two, if you made 98 to 100, you made an A. If you made a 96 to 98, you made a B. You made a C. You made a D. You failed. So when you get your grade, you made a 90, you said, hoo-hoo, I passed. No. And that you'll hear adults, grown adults, hit the floor crying like babies. Hence the wailing wall. They were crying without, you can't control them because their dreams are shattered. They're out of school forever. That school won't take them back because you failed twice. Another law school may take you because of that. Because what a bell curve tells us is this: if everybody makes around the same grade, then the test was too easy. So who's the smartest of the ones? Who made the highest of the grade? Who's the dumbest? The ones who made the lowest of the grades. So you have to look at it that way. So you have to guarantee 50% of your class fails. That's what it tells you. Well, really, Ds are just as good as Fs. So that's, but we'll be using this as a normal distribution from here on out whenever we do anything. Any questions? So be glad when people say, can do you grade on an average or grade on a curve? That's what they mean. Never, ever, ever hope a teacher grades on a curve like this. But teachers, because of that, what teachers do, like in college, early college and high schools and stuff, when they grade on a curve is, let's say the average of the class was 38. Have you ever been in a class that has that average? It happens a lot. You'd be surprised. Even in third, fourth year college grades and in electrical engineering, you'll have classes where the average grade may be below 30 because it's that tough. So what they do here is when they say grade on a curve, this average has to be a 50. So they add 12 points to everybody's scores. That's one way to do it. Another way, they look at the highest score. Let's say you made 72. What would it take to make that one 100? So you add 28 points to everybody's scores. So that's how grade curves work, depending on which level you are. The lower levels do this, the higher levels, and then the professional levels do this. It's up to the instructor themselves. That's why I leave it, whatever it is. That's your grade. All right, so that's the end of that section. Any questions?